Welcome to 3D Optics Tutorials. Today we are going to review reference coordinate systems in 3D optics. First, we need to create a new file. I pre-populated this file so we can just move into the project. Okay, now when we are working in the 3D layout, it is normally necessary to create an optical system that is well-lined and easy to move around. A lot of time can be wasted in moving each component of an optical system. Luckily, using reference coordinate systems is easy and convenient in 3D optics. I pulled in a few CAD mounts so that we can get straight to learning about reference coordinate systems here. To change a reference coordinate system of a component in our optical system, we must first select it in either the outliner bar or 3D layout. We'll go ahead and use the 3D layout. And then we need to go up here to the ribbon bar, click on Move Rotate. And then at the bottom, we can see we have the button to select reference coordinate system. We'll go ahead and click this button. And then a window pops up at the bottom of the 3D layout telling us to choose a reference coordinate system for this part. Since we only have two parts, we'll just select the first mount. So we'll go up here to the first mount and expand it. And here, the second option is the coordinate system. We'll click on that. And seeing these dotted lines, we now know that the reference coordinate system for the highlighted mount, mount number 2, is the coordinate system of the first mount. So we'll go ahead and pin this. And now if we click on the first mount, we can see that it is referenced to the global coordinate system. Okay, and additionally, if we want to see what all objects are referenced to, we can come up to the top taskbar and click Show Link Lines. This will tell us, using these dotted lines, what mount is referenced to what coordinate system. So as we can see, the mount 1 is referenced to the global coordinate system and mount 2 to mount 1. Okay, let's turn that off. Okay, and now that mount 2 is referenced to mount 1, if we grab mount 1, move it around, we can see that mount 2 will follow it around. And if we reposition mount 2, grab the first mount, it will still follow it around in whatever position that we send it to. And if you have a lot of items in your optical system, this is very helpful because you can grab one component and all following reference components will follow it. Okay, let's go a little further. We have a 1-inch lens mount here, so let's grab a lens from the optics catalog. We'll right-click and open Optics menu. We're going to go over here and select Lens Types. We're going to search for a 25.4 millimeter lens. Okay, so we're just going to grab the first lens that is 1 inch. 25.4 millimeters. This will bring it into our 3D layout. And now that we've selected the lens, we will select a reference coordinate system of one of the mounts. So we'll select the second mount that is referenced to the first mount. We'll select its coordinate system. Okay, now if we move the mount to the origin, it will move it to the origin of the mount. We'll back it up a little bit here so we can see it come out the front. There we go. All right. Now the lens is referenced to the mount and it will stay exactly aligned into the mount. And we can again move this anywhere we need. And if we moved the first mount, the second mount and the lens will move with it. Now this nested coordinate system scheme works with as many mounts as you can put in and any objects that you have. So either lenses, CAD objects, or other objects that you put into your 3D layout. Okay. Let's go back to the outliner bar, expand this out, and look at just our parts. As you can see, there is a coordinate system for each one of the components that we've put into our 3D layout. Some components will have more than one coordinate system, and if they do, you can reference any of those coordinate systems on the object. Okay, reference coordinate systems are extremely useful in keeping our optical system well aligned and easy to manage. I hope knowing about this tool will help you build highly accurate optical designs in 3D optics.